Well, now that we've had time to properly define what a limit is, I want to remind us of what brought us to this idea in the first place. The very first section that we talked about was on the subject of rates of change. So we had average rates of change, and we were trying to relate that to instantaneous rates of change. So with that in mind, let's head back to the tangent problem. So suppose that we have a curve based on the function y equals f of x. Associated with the x value a, we have an ordered pair. Since we don't know what the function is, we'll refer to the y value as simply f of a. Now, the idea was in that section that we were going to attempt to create a tangent line at that point and determine what the slope of this tangent line is, known as an instantaneous rate of change. The way that we did so back in that section was to pick a secondary point and move the secondary point closer and closer to the first point. Now that we've defined what a limit is, we can put it in those terms. So we'll say define a second point close to a comma f of a. That is to say, a second point that's actually on the curve. Then take the limit as second point approaches first point. Then evaluate limit using the techniques that we've talked about recently. Now, chances are pretty good you're either going to wind up with a fraction that contains polynomials, a radical, or fractions inside of a fraction, all three of which we've dealt with. Now, like we discussed back in an earlier section, there are two different ways that we can talk about how to define that second point. The first way is to define the second point in terms of your variable x, and just say that x is near a. Now, in the event that you're doing that, your instantaneous rate of change, the slope of the tangent line, is going to be equal to the change in y over the change in x. Then take a limit as the second point approaches the first point. This is defined as the derivative of f evaluated at a. Now, a derivative is representative of a slope of a tangent line or an instantaneous rate of change. There was, however, another way that we defined what this was, and that was by defining the distance between the first point and the second point as h. H for a horizontal distance between the 2 points. In the event that you define it in this fashion, the way that we bring the second point closer to the first point is by allowing that distance between them to go to 0. So set up your y2 minus y1 over x2 minus x1, a plus h minus a, the a's cancel out. Then we force the second point to the first point by taking the limit as h approaches 0. This is another definition of f prime of a. Both of these will always produce the same result, and that result represents the slope of a tangent line at x equals a. What we'll do is we'll do an example problem where we try both of these techniques, and you can make a decision about which one you perceive to be easier. As long as you're comfortable with one or the other, you should be fine for this section. Spoiler alert, you won't be ready for future sections if you get fixated on this one right here. If I'm going to recommend one over the other, get to know this one really well. Trust me. You can't see my face right now, so trust me. Wink.